Okay. So remember on your quiz, the question kind of looks like this, right? Where like I provide you the graph and you guys tell me all the information. What I'm doing down here is it's the exact same thing. Oh, sorry. Thank you. Okay. Sorry, here. Your quiz looks like this, right? And then you guys tell me about all this information. It's the exact same thing as like just kind of going in the opposite direction, right? So that's what these questions down here are doing. So I tell you the information and you have to just plot it and then tell me like, and then just connect the dots basically, right? So the vertex, remember the vertex is like the higher low point, right, of the parabola. So it says that there's a vertex at 1, 1. Okay, well, where is 1, 1? That's what you have to identify. Okay, well, it says x, y. 1, 1 is right here. Okay, that's your vertex. Now maybe I'll do these in different colors, okay? Here we can see. Okay, so that's your vertex. And then zeros. Zeros we called x-intercepts. Okay, so that's x-intercepts. The word intercept means cross, right? In math lingo, I suppose, right? It crosses the x-axis at these 2 points, right? Which conceptually, like that was a lot of words conceptually, but really all you're doing is just plotting these 2 points, right? The exact same way that you plotted the vertex. It's nothing different. They were just putting words to them is all, right? So just go plot those 2 points. Well, where's -2 and 0? Remember, x and y, right? Okay, well, x is always the first, so I just go find -2 and 0 and 4 and 0. Okay, now if you were to connect the dots, right? If we were to connect the dots here, we'd get a parabola that does something like this. Well, does that open up or down? It opens down, right? Because it's frowning. Those aren't points, by the way. Those are just like just eyes. Okay, it's opening down. Okay, the axis of symmetry. The word symmetry is like mirror. Okay, where could you like draw a mirror on this graph such that both halves are equal, right? See, you're not going to draw it here because this side is a lot bigger than this one, right? So where do you draw this line is your question. Well, you draw it right down the middle, right? That's your axis of symmetry, right? What does it do? It creates 2 equal pieces. Okay, how do we know where it goes? Well, it goes through the middle of the graph. The middle of the graph occurs when x equals 1. Remember we talked about if I plotted a whole bunch of points on here, if you told me what all the values of those points were, we'd get something like 1 and 8. We'd get 1 and 4. We'd get 1, 1. We'd get 1, -3. We'd get 1 and -7. Do we all get the point? Like, do we see what's going on? Right? Every point has an x value of 1. Right, so that's what you write down, x equals 1. The equation of this line is x equals 1 because every point along here has a value of x equals 1. Okay. Do we have any questions? Just before I do the last one? Okay, again, it's like I don't know, if you sit and watch the video as you're doing the formative, like, it's gonna help you, right? Okay, at least that way you've kind of like, you've been to the lesson, you watched me do it, then you've like had some productive struggle time with the formative. That's kind of almost what the formative is for. So when you come to the summative, when I ask you the questions again, it's like you're on autopilot, right? The homework's like thrown in there too to kind of like supplement stuff, right? Okay, but especially like under the time crunch that we're on and like being online and everything, there's no time to like get crazy with questions. There's no curveballs. For you not to do well in this is like, it's purely a measure of how much time you've put into just sitting down and watching some videos and the formatives, right? Engagement. A lot of it's engagement. Okay, it's just, we're just scratching the level, but the surface on the material. Okay, not going crazy with questions. Okay? I think some of this is whatever we do in here over the next 10 days, 11 days, right? I think that's the important stuff. Okay, so when you guys go to grade 11, if you at least have that, you're in an okay spot. Okay, so we just got to figure out what the optimal value is. Where's the optimal value? Optimal value sounds like the best. I don't know, best, or in reality it kind of means, well, you could say best. Best means, could mean high point. Okay, that's kind of just my thinking. The high point sounds like, okay, if I'm looking at the graph, the high point looks like it appears right here, right? Well, what is that point? And how do we put that into words? Well, if there's a high point, it means there's a maximum, right? If we have a high point. And there's a max of, what's the value there? There's a max of 1 when x equals 1. That's it. That's your optimal value. That's what I'm looking for. Okay. If you guys would like me to do the next one, please say so. Okay, I mean this one. Or if you think you're good now, we can go down to the bottom. I can show you how to do that question, and you guys can do your quiz. Okay? Please say now or forever hold your peace is the saying, I think, or some version of it. Speak now is the way it is. Okay? I don't know. Can you do one more? I can do one more. That's fine. Okay? Okay? Everyone got that one down? Okay. This is a good question too. Okay? So again, we're just running through. What's the vertex mean? Vertex means the high or low point. It's very, very connected to this. Okay? Synonymous, as they say. Okay? So, let's find the vertex. Where's the vertex? You're just plotting points. Just go plot that point. You're plotting these points. Okay? The thing with this process is it's a little bit more direct in the sense that you're just going to plot the points and then answer some questions, right? The top question a little bit harder from the standpoint that like it requires you to know where to find these things, which I suppose is a little harder. It is harder, okay? But we're running through them now. You can see, if you watch that video, I tried to, and it's a little messy, but I tried to color code everything such that you could see where it was coming from. And it's pretty spelled out for you, I think. Especially with me talking over top. But down here, it's just, you can see it's just plotting points, right? And that's why I emphasize that at the beginning of the course too, right? Can you guys plot points, X and Y? Which most of you can, right? That's the first question on the test, right? About the snowfall, right? It gave you a table of values, and you just plot the points. Right? That's why we emphasize that at the beginning of the course, because when you'll see after, there's a lot of that. Just be like, it's amazing. Even in the like grade 11, kids are still mixing up points. Right? I'm just trying to hit that home a little bit more. Okay, just in my experience seeing kids in grade 11. Okay, so you're just gonna plot this point, x and y. Where's -7? -7's way over here. Where's 2? +2 is right here. Where do these two lines connect? That's how you plot points, right? You're like reading over. Okay, well, there's the point, right? It's 7, 2. Okay, that takes care of that. Okay, then where are the zeros? So the zeros are, again, they're just points. They're called zeros because the y values are zeros. Right? So that means that if you have no y value, it means your height up and down is 0. You're right along the x-axis. That's what it means. All right? So you just go plot those points. -5, 0 is 1. Here, I'll plot them in red. Okay? And the other one's at -9, 0. Okay? All right, well, let's go. What do we do now? Is it opening up or down? Well, let's connect the dots and see what happens. Opens down. Because it's frowning, right? Okay. Now, axis of symmetry. Tell me where the graph gets split into 2 equal pieces. Well, the catch here is the axis of symmetry always has to go through this vertex point from up here. Always has to go through that. That's your clue. It's like almost not even, there's no thinking. You're like, that's the point at which it breaks the graph into 2 equal pieces. When it goes through -7. Right? You've got 2 equal pieces here. Right? And so you say my axis of symmetry, if it goes through x equals -7 all the way, you say x equals -7 is your axis of symmetry. Okay, and just to draw your attention to something, it's not like -7 is pulled out of thin air. -7 is that value there. It's the x value of the vertex. Always. Okay? Then you're going to say, okay, well, what is the optimal value? Again, it looks like we're going to have a high point, right, in this one. If you're thinking of this like a mountain, right, there's like a peak or a maximum height that you could climb to, right? So you're going to say, okay, there's a max here. What is the max? The maximum is max of, or is, it doesn't matter too much. Max is max of 2 when x equals -7. You're basically taking your vertex and putting it into words. The catch is you need to make up your mind as to whether or not it's a maximum or a minimum. You tell that from after you've graphed it. You can see if it's opening up or down. If it were to open up, then you'd have a low spot, be like a valley, which would be low, which would be a minimum. So all that would change in your process is you'd say a minimum of whatever this number is when x equals whatever the number is. Okay, that doesn't change. It's just the wording, max or min. That's what you're deciding. Okay. Everybody okay? So hopefully that clears up if for whatever reason you didn't do the quiz. Doesn't matter, you forgot, didn't know how to do it, needed help, whatever. That's why we're doing this, okay? Take a little step. We'll do the same. So if you guys feel like absolutely lost with factoring, that's 100% okay too, because factoring is just crazy. That's a hard concept right out of the gate, especially over online, right? So we're going to do the same thing. I'll go back and we'll do, I don't know, 10 questions with factoring. Okay, I'll give you a quiz first. You guys can figure out whether or not you can do it. If you can't do it, we'll do some more homework questions. Okay. Okay. Let's go down. Okay. I'm just going to skip that because you have a video of that. So here's what happens. Okay. I like to describe these things as these things. I haven't written anything. This here, I like to describe as it's like a machine, right? It's a machine. Okay, and I talked about this the other day. They're all machines, and then different machines do different things, right? So specifically, this piece here is the machine. Okay. Now, like anything, if I put something into a machine, you're going to apply some process, whatever it is. I'm just making a 100% generalization. A process is going to be applied to whatever you input, and you're going to get something new on the outside, on the other end, right? That something new on the other end is the y value, right? That's what we're trying to find out. What's going on is you guys are inputting things into your machine, and you're seeing what comes out the other end, right? Your inputs are these, right? You're going to input those values where it tells you to put them. It tells you to put it there, and it tells you to put it there. Then you just do the math, and you see what comes out the other end, right? So for instance, if I look at, I'm going to input -5. It goes in where it tells you to put it, right? And you just do the math. It's a calculator exercise, right? So you're like, okay, just plug it in first. That's squared plus 4 times -5 plus 5. Do the math. -5, I'm going to do a different color. -5 squared turns out to be 25, right? 4 times -5 is -20, right? Plus 5. So you just type this in your calculator. 25 minus 20 is going to be +5, plus 5 should be 10. You're just doing the math. All right, well, on the outside here, what you guys can create, you can have like it's like an inventory, okay? And it's like here, I'll write that word, inventory. I keep using that. I've never used this before. So you guys tell me if this makes sense to you, okay? So I'm kind of making this up, the word inventory. I'm not making this up, because that would just be crazy. Okay, the word inventory I'm kind of making up. And what it's an inventory from the standpoint that you had, like, when you walked into the shop to create something, you had an inventory of material, right? And so you're going to keep you're going to keep track of that, right? And then you're going to say, okay, well, I walked in, I put my -5 into the machine, and the machine spat out 10. So you have an inventory of what you started with and what you ended up with, right? So you're like, okay, here's what I started with, and here's what I ended up with. And you're going to do that for all of your inputs that you walk into the shop with. Okay? It's going to keep track of what you have. Okay? And then we can, like, once we have all those points, you can let go of this machine mentality and you just go plot them all. It'll create a picture for you. Okay, that's it. That's all I'm asking you to do. That in itself, this whole notion of like having a machine that does things for you, that's a very powerful concept. Okay, from a mathematical standpoint, right? Just in terms of what you guys are going to be expected to do moving forward, right? You have a machine, the machine does something for you. Keep track of what you started with and what you end up with after the machine does its job. That's all I'm asking you to do. And then plot the points, which you know how to do based on your test. Okay? I don't think anybody messed up plotting points on the test, actually. That was not an issue. So your only hard part of this entire like formative is to do this work in here. Just the machine piece. That's the only thing that's going to be difficult for you. And like once you do it twice, you're like, okay, this is easy. Okay. So let's just do it again. -4 squared plus 4 times -4 plus 5. Okay, I'll keep track of the colors. I'll eventually lose the colors. Okay, but for right now, I think it's important for everybody to kind of see. Remember, what I'm doing is I'm just showing you where the numbers go and where the numbers come from, right? So -4 squared is going to be 16. Plus 4 times -4 is -16 plus 5. All right, well, 16 minus 16 is 0, plus 5 will be 5. So then keep track of your inventory. We had -4, that's what we started with. We walked into the shop with that. Then we said, okay, well, what came out the other end? 5. There's your output. You had your input. Okay, you just keep going. You just keep doing the math. That's all you're doing. -3 squared plus 4 times -3 plus 5. That's 9 minus 12 plus 5. 9 minus 12 is -3 plus 5 should be 2. Walked in with 3 into the shot, -3 into the shot. You left with a 2. Okay? You just keep going. Now, what you're going to notice, we'll get to halfway, and then we'll plot the points, and I'll save you guys some time. Okay? Using a skill or concept from above. Right? So let's just look. Okay, let's just keep going. -2 squared plus 4 times -2 plus 5. -2 squared is going to be 4 minus 8 plus 5. 4 minus 8 should be -4 plus 5 should be equal to 1. Okay, you can see how this is how quadratics work, and hopefully you guys saw this with the cup too, right? You could see how like we started with a big number and it's slowly, and then the difference, and remember what I'm doing, I'm using some terminology. Your first differences appear to be getting smaller and smaller. That's the behavior of a quadratic. Right? So that's how I know the graph is going to do something like this or something, you know? You can see the first differences are starting to slow down. All right? We'll do another one. -1 squared plus 4 times -1 plus 5. That looks like 1 minus 4 plus 5. 1 minus 4 should be -3. -3 plus 5 should be 2. Oh, interesting. Oh, sorry, I didn't keep track of the inventory. Something interesting happened here. It looks like, okay, we went from 10, and then we cut it in half. And then we kind of like cut it in half and took a little bit more. I was slowing down, and then we reached 1. All right, and then we're like, okay, well, in theory, we should keep getting smaller and smaller, right? Well into the negatives. But that's not what happened. What happened? We started going up again. Well, what does that sound like? If I look at the graph, smaller, 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 smaller. Oh, up again. Oops. Smaller, smaller, smaller. Oh, we got to a low point, and then we started going up, 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 up. Right? The catch is, though, I should expect to see, and we'll do the math on it just to show you. I want to get rid of these highlighters, too. I don't want those red. Okay? I expect, and you guys are going to do the same thing. After you've done 3 of these, 4 of these, you're like, okay, I know what this is. I expect these answers to be 5 and 10. Without even doing the math, I expect them to be 5 and 10 because I know there has to be symmetry with a parabola. Symmetry from the axis of symmetry. Right? 10, 10. 5, 5. 2, 2. 1. Right in the middle. Okay? Which means, for this particular question, based on the work that we did up top, this here, when x equals -2, this is my axis of symmetry. It's what cuts the graph's values directly in half. You can see 2, 2, 5, 5, 10, 10. Okay? So I don't need to do these calculations down here. I'll do them right now just to prove to you that they are what they are. Okay? But you guys can do the same thing once you reach this point, once you've found what the vertex is, right? So another thing is, I erase this red line here. This is your vertex. It's your vertex because it's splitting the graph in half. Okay? So let's do the math down here and make sure that we're right. 0 squared plus 4 times 0 plus 5. That looks like 0 plus 0 plus 5. Oh, it's 5. Very good. Okay, let's do the next one. 1 squared plus 4 times 1 plus 5. That looks like 1 plus 4 plus 5. That looks like 10 to me. Right? And so you get 0 and 5 for that inventory point, and you get 1 and 10 for that point. The only thing left to do now is to go map what you created, what you walked into the shop with, and what you left with. That's the only thing left to do. Does anybody have any questions before I go do that? Okay? You walked into the shop with a bunch of stuff. You threw it into your machine, and you got new product out the other end. Your job is to go down and plot what you walked in with and what you left with as a series of points. That's your only job. You'll create a quadratic, a nice little parabola. Okay, so let's just go do that. I need point -5 and 10. I need -4 and 5. Okay, I need -3 and 2. And then I can see, so you see what's happening, eh? With the graph. And then -2, 1. Look at. That looks like a quadratic to me. It's starting to slow down, right? Now, just plot the rest of the points. -1 and 2. 0 and 5. 1 and 10. Connect them. That's all I'm asking you guys to do. Where's the vertex? Right here. what is the vertex? -2, 1. Where's that? Oh, right here. We identified it from the table already. What's the axis of symmetry? Axis of symmetry is x equals -2. Splits the graph into 2 equal pieces. Where's x equals -2? Oh, it's right here. That's what we said already. Okay. Any questions? Okay, at the very least, hopefully you guys can I'll post this too. That went better, and I think